Solving systems by substitution, day 1. To begin with, we're going to use the simplest form of substitution, and that is going to be substituting an ordered pair into an equation. So as you can see, we've got these two equations, 3x minus y equals negative 6, and negative x plus 2y equals negative 8. We actually did this before with inequalities. We are going to take our x and our y and replace these into each of these equations. So for the first one, that is going to be 3 times x minus y equals negative 6. So x is negative 4. 3 times negative 4 minus negative 6. Is that equal to negative 6? Well, if we type that in our calculator to see if it is, this is positive 6, negative 12. That is negative 6. This is a true statement. Now let's see about the second equation. It has to be true in both of these. Negative x plus 2y equals negative 8. If we take our x of negative 4 and our y of negative 6, let's see what we get. That is 4 minus 12, which is negative 8. That is also a true statement, and that means that this is a solution. Okay, let's try that into the second one. Take our x and y, 2 and 4, replace these so we get negative, negative x, negative 2, plus our y is 4. Is that negative 3? That's actually positive 2. So that is a false statement. False statement. Since it has to be true for both of them, automatically we know the answer is no. But it's probably a good idea to plug into this one as well. Negative 2 plus 3 times 4 equals negative 13. That's 12. That's 10. 10 is certainly not equal to 13, negative 13, so the answer is no. But again, it has to be true for both equations. It has to make both equations true. Okay, number 3, we begin what we are going to really become and know well is the substitution method for solving equations. So first thing we are going to do, very first thing, is pick an equation. It matters because we want to pick an equation where either x or y or some variable is by itself. Now if you notice on 3, both of these have y equals and x equals. Okay, so both of them have a variable completely by itself, isolated. I'm going to pick this second one right here, x equals 2. Now the reason that I want to do that is what we're going to do is take the other equation, and instead of an x, we are going to replace, we're going to substitute. And this is step 2, 3x plus 1. So we are going to put in 2 where the x was. So x is 2, so we're going to replace it right there. And that will give us y equals 3 times 2 plus 1, which means y equals 7. Now our third and final step, because we have y now, is we really want an ordered pair. So y is 7, x comma y. Now in this case we actually go back to this equation right here, x equals 2. Now in this case that is a really obvious statement. X equals 2, so therefore our answer is 2 comma 7. That will be a little more complicated than the next one. Okay, so we start with one of them that has either x or y by itself, use that into the other equation, substitute that in, solve that equation, whatever we get 7 in this case, and then go back to that first equation. Kind of go full circle. Hopefully that'll be more clear in this next one, number 4. So first we want to pick an equation that has x or y by itself. The clear choice for number 4 is that second equation, y equals x plus 7. All right, now for step 2, we are going to go into this first equation, and we're going to replace y with x plus 7. So the equation is y plus 2x equals 19. But instead of a y, we are going to write in x plus 7. Okay. So we have x plus 7 plus 2x equals 19. So we need to combine like terms, so that's going to be 3x, because that is a 1x. So we get 3x plus 7 equals 19. Using things we've done for a long time solving equations, we will subtract 7. That's 12 equals 3x. Dividing by 3. We get the x equals 4. That's great. Okay, so in our solution, we have x equals 4. But our last step is going to be to find out what y is. Last step, we're going to go back to our equation we started with, y equals x plus 7. Replace x with 4 because that's what we found it to be. So y equals 4 plus 7, which is 11. Y is 11, and that is really what we're after. We want these two together to be that ordered pair, 4, 11. Now it's a really good idea to take this point and plug it in here. So that would be y, that's 11 plus 2 times 4, is that 19? Okay. And the next is 11 equal to 4 plus 7. Both of those are true, so we can use that first substitution to check the second. Okay. Moving on to number 5. First step, pick one of our equations where we have x or y by itself. The obvious choice here is first equation. So we're going to take that and plug it into our second, or substitute it into our second equation. So step 2, we're going to take y minus 5, this is where x would go, equals negative 3. So we are going to put in 6 plus 2y. Right, there's where x would go. 6 plus 2y. Now in this case, we're going to have to distribute. So we get y minus 30, and then we have minus 10y equals negative 3. Combining like terms, we get negative 9y minus 30 equals negative 3. Adding 30 to both sides, negative 9y equals 27. Dividing by negative 9, y equals negative 3. So in our solution, something comma negative 3. Should be pretty obvious. The hard part is this second step right here. All right, third step. Go back to your original equation. X equals 6 plus 2y. But we're going to replace y with negative 3. All right, so 6 plus 2 times negative 3. That is actually going to be 0. So x equals 0. And our solution is 0, negative 3. Number 6, first step, pick an equation with y or x by itself. In this case, it's going to be that second equation. Now in future days, it may not be so obvious. Okay? So we want to see one where we have just a y or an x by itself, or we might have to get that to rearrange it to get x or y by itself in the future days. So obviously it's going to be this one this time. Now we're going to take 3x, and we're going to plug that in, 3x plus negative 5x plus 9. Okay, and that's going to equal 9. Replacing this guy all where y is. All right, that's going to be, if we combine like terms, that's negative 2x plus 9 equals 9. Subtracting 9, we get 0 on both sides, 0 pair. It's negative 2x. Dividing by negative 2, we get that x equals 0. So in our solution, we have 0, something. Third step. Take the original equation, y equals negative 5x plus 9. but instead of an x, we're going to put in a 0 because that's what we found that x was. That tells us that y equals 9. For our solution is 0, 9. Now again, I'm going to plug that in up here. 3 times 0, that's 0, plus 9 equals 9. Yes. 9 equals -5 times 0 plus 9. Yes. Both equations is true, and that's it. Number 7. Which one of these do we have where x or y is by itself, or close? First equation right there. Like on number 8, it's going to be that second equation. All right, now next step, we're going to take y and replace it in this other equation with this stuff right here, with 2x plus 8. So our equation is going to be 3x plus 2 times something equals 9. Well, y, so that's 2x plus 8. Okay, distributing, we get 3x, and that's going to be 4x plus 16 equals 9. We'll bring down the 3x. So we get 7x plus 16 equals 9. Subtracting 16 gives us a -7. So 7x equals -7, dividing by 7, x equals -1. Our solution is -1 comma something. Third and final step, go back to the original equation. That's y equals 2x plus 8. But we're going to substitute in -1 for x. That tells us that y equals, that's 8 minus 2, so 6. Therefore, our answer is -1, 6. Now again, I'm going to go and plug these in just in my head real quick. Y, so that's 6 equals 2 times -1 plus 8. Yes. Okay, and then next we have 3 times -1, it's -3, plus 6 times 2 is 12. -3 plus 12 is, in fact, 9. So therefore, our answer is, in fact, -1 comma 6. Right, number 8, we've already completed the first step by picking that equation, the one that's easiest to get y or x by itself. Our second step is going to be to replace y in the other equation with x plus 5. So 4x plus y, which y is x plus 5, and that equals 20. So distributing and combining like terms kind of in one step there, we get 5x plus 5 equals 20. Subtracting 5 from both sides, 15 and 5x. So dividing by 5, we see that x equals 3. Again, in our solution, that's 3 comma something. Now, third step, we are going to take that value, 3, and replace it in the original equation. Y equals x plus 5. So, scrap the x, put in a 3. So that tells us y equals 8. So our solution is 3 comma 8. Okay, so 3 plus 5 is in fact 8. 4 times 8 is 32 plus, no, hold on, 4 times 3, 12 plus 8, that's 20. So that is in fact true. Okay. Number 9. First look for the equation where x or y is by itself. It's written backwards, but that would be this first equation. And in number 10, that's going to be the second equation. All right, now let's see if we can substitute this in. So step 2, we're going to replace, so we're going to use this other equation, 2x plus y is 5. Okay, now replacing the y term with negative 2x plus 5, negative 2x plus 5. Combining like terms, we get 2x and negative 2x. The x's cancel out, so we get 5 equals 5. Now, we ran across this a long time ago, in a galaxy far, far away. We ran across this before because we found that when we ended up with just a true statement, our variables cancel out. What really is happening here is that this equation is always true. And in fact, this is a true statement, so our answer is actually going to be all real numbers. All real numbers. Okay, infinitely many solutions. I'll go ahead and write that too. Infinitely many solutions. Okay. Which means any ordered pair you plug in will make both of these equations true. Any ordered pair will work. And the reason that's the case, okay, is that these are actually the same equation. If you solve this one for y, let me just go ahead and do that. If I solve this one for y, I get y equals negative 2x plus 5, which is exactly what that first equation was. So therefore, if you have two things that are the exact same, remember coincident yesterday, where we had the two lines that lie directly on top of each other? They're really the same line. That's what happened here. These two are always at the same place at the same time. All right, number 10. We've already picked our first equation. All right, now let's see. For step 2, we'll replace y with negative 3x plus 2. So that's negative 3x plus 2 plus 3x equals 0. There's where we substituted in. Well, again, the variables cancel out. We have negative 3x and 3x. So what we have here is 2 equals 0. That is a completely false statement. So therefore, our answer is going to be no solution. Now, if you remember again, inconsistent, okay, we have two lines here that really are parallel. They're parallel, they never intersect, therefore there is no solution to this system. Okay. Number 11, the length of a rectangle is 3 less than twice the width. The perimeter of the rectangle is 30. Find the dimensions. All right, so we get to write a system here. So first, let's see if we can relate these two here. So the length of a rectangle is always translates to equals. So the length is, I'm going to go ahead and use L for the length, is 3 less than is a backwards word, twice the width. So let's say twice the width minus 3. I'll go ahead and write this down here. L equals 2W minus 3. All right. Now let's see the perimeter. There's one equation. The perimeter is 30. Well, the equation for perimeter of a rectangle is 2L plus 2W equals, well, in this case, 30 because that is the perimeter. So this becomes a substitution problem system because we have an L already by itself. So that's step 1, pick that equation. Step 2, we're going to replace L down in this equation with 2W minus 3. Okay, so let's see, let's take 2W minus 3. Distributing, we get 4W minus 6 plus 2W equals 30. So that's 6W minus 6 equals 30. Adding 6, that's 36. So 6W equals 36. Dividing by 6, the width equals 6. Well, we have to find both dimensions. So our step 3, just like we had earlier, we're going to go back to our original equation, L equals 2W minus 3. But we're going to replace W with 6, which tells us that our length is 12 minus 3. Our length is 9. That's all there is to it. Okay, number 12, last question. The difference between the regular price of a book, R, and the sale price, S, is 24. The regular price of the book is 3 times the sale price of the book. What is the sale price of the book? So we are after S here. All right, so first, difference between the regular price and the sale price is 24. Well, the difference means subtraction. So if you take R minus S, we get 24. There's one equation. Great. Next thing we've got is the regular price is 3 times the sale price. Regular price is 3 times the sale price. R equals 3S. Step 1, I'm picking this equation right here. R equals 3S. Step 2, R minus S. So we're going to have R minus S equals 24. In this case, we're going to plug in 3S, because that is what R was. So that becomes 2S. 2S equals 24. 2, S equals 12. So the sale price is $12. All right, now we could use that to find the regular price, but do we care what the regular price is? Here's our question. What is the sale price? There's the sale price. We don't need anything else. All right, that's the end of substitution day 1. Now, keep in mind, checking your answers with the calculator, okay, plugging them in, substituting them in like we did in numbers 1 and 2 is really important, and we really should be doing that this whole way. All right, that's it.